Assalamu alaikum wa rahmatullahi wa barakatuh. Today, inshallah, we will continue on our revision for the next classwork. As we spoke previously about the topics that will be covered in the second classwork, we are going to cover higher order differential equation, which is very, very important. Steps here are systematic. We need to understand the steps and to do it performing exactly as explained in the lectures. Then you will have a couple of questions about Fourier expansion. We need Fourier expansion in partial differential equations. Then you will have power series, which represent a very simple part of this exam. You will have a couple of questions about arithmetic or geometric functions, geometric sequences, and you already know about them. Then you will have the tests for the convergence or divergence for some of the general terms of these types of functions. Then we will go through partial differential equations, either by the various methods that we used. Mainly separation of variables is one of the best or one of the major methods that we use. You told me that the classwork 3, I've already updated the time for the classwork for the third classwork. It's going to be on the 18th. You find it on the 18th, yes? Okay. It was previously written on the 14th of April, but then we updated to be on the 18th of April.
مكتوب 18 فوق. مكتوب 18 فوق.
اوكي فين؟
فوق.
اوكي يبقى انا updated هنا بس ما عملتش. اوكي. طيب بعدين انت عندك الفاينل كلاس وورك which is going to be by the 21st of April. I think also I've raised it on campus. Please do check. This is the final class work, and it will cover both class works, the topics that have been done with class work 1 and the class work 2. This is going to be 40% class work, and it's going to be the end of our course. Our course in this semester, as you know, is 100% class work. Okay, let's go through Fourier series. The main idea behind Fourier series is how to represent a certain function on a periodical effect. This is going to be done using this expression. It states that you have a naught over 2, then a sum notation from n equal 1 up to infinity for the term, for the constant an cosine n pi x over L plus bn, which is another constant, times sine nbx over L. The main idea of Fourier is to identify a naught, an, and bn. Okay. If your function is not an even or odd function, you will have to evaluate a naught, which is going to be 1 over L, for starting from negative L to positive L, for the function f of x, which required to be repeated, times dx, or with respect to dx. Remark that L is the half period of repetition. نص الفترة بتاعت التكرار. بالتالي فورير ايه الهدف منه؟ ان انا امسك فانكشن اخليها to repeat itself through a specific period. ده الهدف الأساسي من فورير. طبعا ال an exactly the same with a slight difference. نفس ده بس اعمل هنا multiplication times cosine n by x over n. يعني بص مستر زيد an already مضروبة في cosine. كل اللي يحصل نفس الانتجريشن ده بس انا هاجي على الانتجريشن ده اروح حاطط جنب ال f of x cosine n by n times by x over n. In a similar manner, bn for the sine part. There is an advantages you can find using or understand when you understand the type of f of x. If f of x is an even function, لو الفانكشن بتاعتك even function f of x, يبقى ده معناه ان انا ممكن استفيد ان الساين تيرم او البي في الحاله دي through integration is going to be equal to 0. So your expansion will be bn equal to 0. That's the expansion form will contain a naught and an just only possible. بعدين هاخد advantage من properties بتاعت definite integration. One of the major properties of definite integration is that if you have f of x and it's an even function, instead of integrating from negative L to positive L, you can use from 0 to L and multiply the value times 2. It's a huge advantage in integration, and it will minimize the time for substitution by the integration limits. In a similar manner, if you have odd function, you will have a naught, both a naught and an equal to 0, and your expansion will be just only as a sine part, so you will have only to evaluate the term of Bn. This is actually the case that, which is repeated more than once with us in partial differential equations, that we are using the final case scenario of having Bn equal to or L integration from 0 to L f of x, and then you have an expansion for the function expressing the separation of variables either in the wave equation or in the heat transfer equation. Okay, let's do a problem. This is a main problem which contains all the steps in general. In this part, you may be asked about the laws, when, what's the suitable law that you can use in order to find the solution for a certain problem, or you will have a problem like this stating most of the evaluations and the general steps in handling a function with field. The first requirement is asking you to sketch the function through the interval from negative line up to positive line. So I need to draw this graph from negative line to positive, showing the periodic effect, showing how this function is repeating itself. So the main idea is to draw the function in the stated period. So the first step, I will say, this is y-axis, this is the y-axis, and that is the x-axis. Be the step number 1. Main function, x over 3. That's the main function, x over 3. And the main period is from negative 3 up to 3. Let's start graphing this function, which is a straight line function, through the interval from negative 3 to positive 3. Okay, once you substitute x with negative 3, ايه؟ عشان لما تعمل ريبيتيشن هنا يبان البريودستي افكت. فانت فيرست ستيب زين برسم الفانكشن بتاعتي ثرو المين انترفال، اسمها المين انترفال. ابدا ارسم بقى. يبقى لما احط 3 هيدي لك 1. يبقى انا لما اجي هنا عند 3 x بتساوي 3 الواي will come up to 1. Once you go to x equal to negative 3 the value of y will be negative 1. ادي الفانكشن بتاعتك نيجاتيف 1. لذلك هتلاقي اللاين بتاعك او الفانكشن ده الشكل بتاعها. يبقى ده المين فانكشن، بس ده في انهي بيريود؟ ده الماستر بيريود، المين بيريود. يبقى اذا انا عارف ان البيريود بتاعتي دي اللي هي 2L دلوقتي بتساوي كام؟ بتساوي 6. كده انا مش خلصت، انا لازم طبقا اللي هو required انك to graph this function through the interval from negative line to positive line. All I have to do is to take this period and move it to the left and to the right. ده ب 6 يبقى السكند period اللي انت بتتكلم عليها يبقى 3 and it will reach 9. يبقى من 3 بلس 6 يجي لك 9. سيمولي لاين ده نيجاتيف 3 يبقى يجي يمالي عن نيجاتيف 9. بعدين هاخد ده وهبدا من هنا وريبيت الشكل بتاعي ده بنفس الاسلوب بالظبط. يبقى ده الشكل بتاع الفانكشن. طبعا ده نيجاتيف 3 هتلاقي ان ده نيجاتيف 6 وانت هنا عن نيجاتيف 9. سيم واي لايك طبعا هتلاقي الفاليو دي ب 6 وهتلاقي الفاليو دي ب 9. بعدين الفانكشن will also in a similar manner will repeat itself up to infinity. يبقى ده الشكل بتاع الفانكشن بتاعتك. اللي بيحصل ده المين بيريد. اللي بيحصل تتكرر يمين وهكذا وتتكرر فين؟ في الاذر سايد. ده الافكت اللي بيحصل وانس انك بتبدا تعمل اكسبانشن يوزنج فورير. طيب you will find the Fourier expansion for this function. عايز بقى ابدا اشوف Fourier expansion. From the first block we are dealing with f of x equal x over 3. الفانكشن اللي انا بتكلم عليها دي رقم 1 اتس ان اوت فانكشن. اذا انا ما خدتش بالي من الفانكشن شيب اتس ان اوت فانكشن يلفت انتباهك على طول from the graph that you have symmetry about the origin. So you are dealing with an odd function. What is the advantage of dealing with an odd function? With respect to Fourier, you will have a node equal am and both of them are equal to 0. This is step number 1. So actually, I'm going to use the expansion that states that an f of x will equal to the sum from n equal 1 up to infinity for Bn of just only sine n by x over L, which is هنا لما يبقى عندي 2L equal 6 يبقى إذا ده معناه على طول إن ال بتاعتك بتساوي كام؟ بتساوي 3 يبقى ده معناه إن أنا بوجد اكسبانشن for Bn sine n by x over 3 وده الاكسبانشن اللي انا بحاول اجيبه دلوقتي from n equal 1 up to infinity. طيب عشان اقدر اوجد الاكسبانشن ده يبقى انا كل اللي انا محتاجه ان انا اوجد الفاليو اوف بي ان وانا عارف ان البي ان الكلام ده بيساوي 2 over L integrating from 0 to L for the function which is x over 3 times sine n by x over L with respect to dx. Direct application on the menu. طبعا in exam I would recommend graphing or sketching, it's a must. Stating which constants equal to 0, it's also a must. The marks are already on them. Using the specific expansion form that you are dealing with, this is where you have marks also. Then start substituting and integrating and you are done, which is really easy. طبعا لما اجي ابدا اعمل السبستيوشن بتاعي يبقى عندي 2 over 3 integration from 0 up to 3 for x over L sine by x n by x over 3. It will be integration by parts. So I will choose sine to integrate. Once you integrate sine, it's going to be negative of cosine n by x over 3 times 3 over n by times the first function which is x over 3. بعدين minus, we already have negative sign, so it's going to be positive. Start to accumulate or to get all the numbers outside, so it's going to be 1 over n times y for the integration of a cosine of n by x over 3 with respect to dx. يبقى إذا الجزء الأولاني اللي هو عملت فيه الانتجريشن بتاعي بعدين عملت simplification بقى 1 over n by بعدين عملت differentiation with respect to x you end up having cosine n by x over 2. Start integrating this part, so it's going to come up to 3 over n square by square and then this term is going to be sine n by x over 3 plus a cosine of an n by x over 3 times x over n by times 2 over 3 and this is your bn. Then I will start substituting by the integration limits. The integration limits is 3 and 0. Another start substitution with 3 and 0. Once you start substituting with 3, you will have for this part 3 over ny, cosine ny. But remember that this term is going to come up to 0 because you will have cosine ny. So the first substitution will get to 2 over 3, open your bracket, cosine n bar times 3 over n bar. So it's time 3 and all of them over n times 1. Once you start substituting once more with 3, 3 over 3 sine n by 2 n equal to 0. Once you re-substitute with 0, x will make the first term equal to 0 and sine also equal to 0. So this is the last term, or this is the only term that exists, which means that Bn will equal to 2 over n by times negative 1 to the power of n. And that's it. Now I have the expansion for this function. That's f of x will equal to 2, will equal to the sum from n equal 1 up to infinity of 2 over n by times negative 1 to the power of n times the function by itself sine n by x over 3. That's the final expansion using Fourier. لاحظ عندما مشيت الانتجريشن باي بارتس بعدين لما عملت سبستيتيوشن استخدمت النولج اللي انت المفروض فاكره اللي هو بيقول ايه؟ ان انت عارف ان كوزاين ان باي ده بيساوي نيجاتيف 1 to the power of n وان كوزاين ان باي اوفر 2 ده بيساوي 0 كمان الساين بتاع ان باي equal to 0 وساين اوفر n باي اوفر 2 equal negative 1 to the power of n plus 1. Those are mainly the main points or the keys that you will end up in every problem, almost every problem. You will end up using them or needing these values. And it will give you a series, as you can see, from n equal 1 up to infinity for this extension. الجزء بتاع فورير مهم. يبقى انت عندك higher order شفنا المره اللي فاتت بعدين شفت وراه على طول الجزء بتاع فورير انت معرض ده. اوكي؟ تمام جميل. طبعا I would recommend انه at least you can solve a couple of problems on Fourier, 1 or 2 problems. It will be very nice. Okay. طبعا بعد كده انا كلمتك على الجزء بتاع السيكونسز. Some of them are really very famous, like the arithmetic series. You already know about the general term, which is simply a1 plus n minus 1 times d. a1 represents the first term. d is the constant distance between the difference between the first term and second term and so on. You have also the formula for the summation of n terms, and maybe you will have a problem or two on this part. I think this is really very easy part with respect to you all. You already did go through it previously in Mass 2 in IFB. Once more, you will go through geometric progressions. And general term for a geometric progression equal to a1 times r to the power of n minus 1. Of course, Sn is going to equal to a1 times r over n minus 1 divided by r minus 1. The main difference between geometric and arithmetic, as you already know, in arithmetic progressions, the differences are equal, but in geometric progressions, the ratios between the second and the first, the third and the second, it's going to be a constant ratio. Okay, we already studied all of this, arithmetic and geometric, because we are going to negotiate if the series that you are working with or the sequence are divergent or convergent. Also, one of the famous types of these sequences, the P series, which states that the form will be like this: 1 divided by 1 to the power of v, 1 divided by 2 to the power of v1, over 3 to the power of v, and so on. This function represents, or the general term is going to be 1 over n to the power of b. B indicates the type of this P series. If B, the mark, and this is very, very important, if B is greater than 1, if B greater than 1, your series will converge. But if B is less than or equal to 1, the series is divergent. And as we did go through this previously, we are going to negotiate the convergence of series. One of the main tests, we already have the ratio test, the comparison test, the quotient test, the integral test. So you will have to solve all of this. I've chosen one of these problems in order to refresh the steps. Like this one, I want to discover if this series converges or diverges. Okay, and I would recommend that you go once more through this part in your main lectures. Okay, but just in case if you want to remember, once you look to this general term, you will find that it's all multiplication division. There is no addition and subtraction. Okay, once we are dealing with this, so a ratio test will be a very good choice for you. Okay, what does the ratio test states? The ratio test states simply, if you want to discuss or to discover if this general term or this series is going to converge or diverge, really very simple. All I have to do is to get limit n tends to infinity for an plus 1 divided by an. If the values, remember in the ratio test, if the value of this limit was something less than 1, if it was less than 1, then you have a convergent series. If the limit value was greater than so that it's going to be divergent. Or if it equal to 1, if this limit come to 1, if this limit comes to 1, this means the ratio test will fail, and you will have to choose either from the bunch of other tests that you didn't go through, the quotient test, the comparison test, the integration test, but the ratio is going to fail. Okay, let's discuss the steps of this test. First of all, I would like you to get an plus 1, which is really very simple. All you have to do is to make a substitution, replacing every n by 10 plus 1. So I will have 10 to the power of 2n plus 1 divided by 2 over n plus 1 minus 1. Take care in ده كله معمول له factorial. طبعا I would recommend انك to simplify it as much as possible. So it's gonna be 10 to the power of 2n plus 2, that's 100, divided by, once you start expanding this part, it's going to be 2n plus 2 minus 1, that's 2n plus 1 factorial, and I need to be as much as close as an. It will let me out once I start substitution. That's, we have 2n plus 1 times 2n times 2n minus 1 factorial. لاحظ يا زين انا بحاول اخلي المين فورم بتاع an يبقى already embedded in an plus 1. That's an plus 1. Once more, I will start substitution. I was substituting in this form, so it's a limit of n tends to infinity. I will replace an plus 1 and use the explicit form, so it's 100 times 10 to the power of 2n, which is simply divided by 2n plus 1 times 2n times 2n minus 1 factorial. And I will divide it on an. an is the general term, so it's going to be times 10 to the power of 2n, and this one is going to be 2n minus 1 factorial. Let's start to simplify this as much as possible. You will find that this is the factorial terms. It's going to be cancelled with each other. You have 10 to the power of 2n, it will be cancelled with 10 to the power of 2n, and your expansion will come up to limit n tends to infinity for 100 divided by 2n plus 1 times 2n. And then I will start taking the limit for this function. Once you start taking the limit for this series, you will find that it will equal to 100 divided by infinity, which is going to come up to 0. That's less than 1. Yet this series is a convergent series. يبقى السيريز بتاعتك دي ايه وضعها؟ convergent. يعني ايه convergent؟ يعني once you go to infinity, the value of this function will approach certain value. It's not going to approach infinity in any way. So this is mainly a part of our next assessment, inshallah, which handles the various tests. I would recommend that you solve a couple of these problems. Okay, this is for the ratio test. Here's the steps, exactly the same we did go through. Once you reach the final step, you will find the limit. After you take the limit, it's going to equal to 0. So that's a convergent series. Now I want to speak about the part which handled the partial differential equations. In partial differential equations, we really did go some definitions. I've already raised a video for this, talking about the types of partial differential equations, how to classify them, blah, blah, blah. Then this is one of the famous problems. It represents how to understand or how to find an arbitrary function, especially if the solution was given as an arbitrary function. And you will show that if nu, which is the main function, can be represented by oxi of y1 and 3x, where oxi is any function on the form of y1 and 3x.
3x. It could be sine y minus 3x. It could be e to the power of y minus 3x. It could be a square root for y minus 3x. It could be a quadratic function in y minus 3x. So, what we are stating here, any function that's a function in y minus 3x can be a solution, a successful solution for the partial differential equation, which is partial u partial x theta plus partial x, I'm sorry, plus 3 partial u partial y. The first part is going to be really very simple. All you have to do is to start differentiating in order to get the left-hand side. So I will start with the left-hand side. As you can see, the left-hand side states that you need a differentiation with respect to x and another differentiation with respect to y. So the first step, I will try to get partial mu partial x, which is going to be, this is the main function. Start differentiating with respect to x. Once we differentiate with respect to x, you will have psi dash of y minus 3x times negative 3. In a similar manner, I will try to get partial mu partial y, which is going to be, I'll start differentiating also eta with respect to y. Once you start differentiating, you will have psi dash of y minus 3x, but here we are differentiating with respect to y. That's derivative of y is going to be 1. So this is the first step. The second step, I'm going to get the left-hand side. Left-hand side, which states this part. So all I have to do is to rewrite partial eta partial x plus 3 partial eta partial of y, which is going to equal to, start substituting. So I'm going to have negative 3 times psi dash of y minus 3x, then plus, I will multiply 3, okay, times the derivative with respect to y, which is simply psi dash of y minus 3x, and this is going to equal to 0, which equal to the right-hand side. Then again, over here, in the left-hand side, instead of the right-hand side, if you use any arbitrary function, but under just only one condition, it's a function in y minus 3x. طيب بعد ما هو عمل كده طلب منك انك توجد then find the particular solution. Start finding the particular solution, which states that for an u with x equal to 0 and any y is equal to 4 sine y. Okay, perfect. So the first step. Now we know that the general solution for this partial differential equation is simply mu of an x and y equal to psi of y minus 3x. The condition states that just only when u equals 0 and y, so that's if you substitute here with y equal to 0, I'm sorry, with x equal to 0, you will have psi of a y, which is going to equal to, under this condition, it's going to equal to 4 of sine y. So this is going to equal to 4 times sine y. Within the psi function, this is the function in y, which equal to 4 sine y. So it's going to lead to, that's psi equal 4 of a sine. This is the function, which could be a function in y, 4 sine y. A function in x, 4 sine x. A function in y minus 3x is going to be 4 sine minus 3x. So that's the particular solution. It's going to be psi of y minus 3x, which equal to 4 of a sine y minus 3x. ده معناه ان u of x and y will equal to 4 of a sine of a y minus 3x. This function here, if you would like to expand it, you can. لو أنا حبيت إن أنا to expand sine y minus 3x, you can expand it. So I would recommend إنك to write it this way. So it's going to be 4 of cosine of y minus, sorry. A 4 of cosine y times sine of 3x, then minus sine of y times cosine of 3x. All of this times 4, and this is your final answer. يبقى انا كل اللي انا عملت اكسبانشن للساين اوف y minus 3x. خلي بالك ان البروبلم دي بتمشي على ستيبس. الفيرست ستيب انا وضحت ان ده السولوشن، السكند ستيب بدات استخدم الكونديشن اللي عندي عشان اقدر اوصل للبارتيكولار سولوشن. طبعا لو انت وقفت هنا مفيش مشكله، انا هدي نص درجه زياده لو انت عملت اكسبانشن. بس ده لو اصلا الفانكشن بتاعتك كان بي اكسباندد، لان في فانكشنز ممكن ما يبقاش فيها اكسبانشن.
مثلا
عادي. اوكي بيرفكت. المساله دي مهمه متغالبه، يبقى عندك واحده زي دي. انزل. انا عايز احل معاك تاني على السيبريشن. السيبريشن اوف فاريبل تعتبر واحده من اقوى الطرق اللي اتعملت لمعالجه بارشل ديفرنشال ايكويشنز ان جنرال. عندي السكسسفul انتجريشن ميثود، عندي الدبل انتجرال ميثود، بعدين عندي السيبريشن اوف فاريبلز ميثود. السيبريشن اوف فاريبل ميثود one of the very nice methods. It's a systematic technique. You don't have to exert much in it. Just only take care from the first assumption that we will use. We will consider this function to be separable. In order to solve this function, all I have to do, it's a steps. The first of them, I will state that I will consider u, which is mainly your function, as a multiplication of two functions. One of them is a function in x and the other a function in t. This is for the general function. Okay, taking this knowledge، وعلى فكرة ده بالظبط اللي احنا كنا عاملينه في يعني قريب من الستبس بتاعت المثال اللي فات. أنا هفضل إن يو هنا بتساوي اكس تايمز تي، ده الجنرال سوليوشن. طيب تعالى بقى نعمل بيه سبستيتيوشن. عايز أعمل بيه سبستيتيوشن. لو أنت خدت بالك أنا دلوقتي عايز أجيب partial 2u partial x squared. So I will differentiate this twice with respect to x. If you differentiate this twice with respect to x, that's u xx will equal to x. Just a second, I'm sorry. It will equal to x double dash times t. And in a similar manner, I will try to get, okay, u of t, which is the double derivative of u with respect to t. Also, the part that's going to be affected by this derivative, it's the t part. So you will have u, which equal to x times t to the power double dash. Now I will try to, I know that once we already assumed that u is an x of t, so we can use this formula. That's, خلي بالك يا زين، ان x double dash t will equal to c square x times t double dash. السنة دي مهم جدا. يبقى انا كل اللي انا عملته، يا ريت تخليك معايا، دي فعلا مهمة. كل اللي انا عملته انا فرضت يو اكس وتي. بعدين انت محتاج يو متفضل مرتين with respect to x. يبقى مين اللي هيتفضل؟ الجزء اللي فيه الاكسات، يبقى x double dash. وده هيبقى partial 2 partial t square. انت تعمل derivative with respect to t. مين اللي هيحصل له derivative؟ التي بارت. That's ان هيبقى عندك لما تعمل substitution x double dash t equal c square x t double dash. الستيب اللي بعديها ودي اللي يجيب لنا اسم الطريقه. I will try to separate them. شوف بقى لما اجي اعمل separation اروح واخد x double dash over c square in x وطبعا هيساوي t double dash of t. يعني ده will lead to ان x double dash over c square x will equal to t double dash over t. في المرحلة دي أنا دلوقتي أقدر أعمل أهو حاجة بالشكل كده. عملت سيبريشن. هفرض إن الفاليو دي على بعضها بتساوي نيجاتيف لامدا سكوير. اشمعنى نيجاتيف لامدا سكوير؟ لأن أنا عارف إن كمان شوية هضطر آخد سكوير روتس، فبدل ما أفرض نيجاتيف ام ولا نيجاتيف ان فهتعامل مع روتس، فضلت إن أنا أفرض something to the power of 2. عشان بعد كده ابقى مش هستك مع روتس. تعالى بقى سيبريت ده، يبقى ده معناها ان x double dash over c square of x will equal to negative lambda square. يوم ده معناه ان x double dash plus lambda square c square of x will equal to 0. الستيب اللي بعديه ده هيديلك ان d square plus lambda square times c square في x equal to 0. That's خلي بالك لو انت ده اللي كنت ماشي فيه الصبح، انا كده هاير اوردر ديفرنشال ايكويشن هوموجينيوس، انا ماشي على الستبس بتاعت الهاير اوردر. عندي واي دبل داش بلس لامدا سكوير سي سكوير واي، خلي بالك جبت ديفرنشال اوبريتور اللي هو عباره عن دي سكوير زائد لامدا سكوير سي سكوير تايمز اكس. الاكس اللي انا حاططها دي انا اوريدي عامل لها اسامبشن في المين ميثود ان اكسبوننشال فانكشن، فلما بعمل ديريفيتيفز ليها بتتحول لكاركترستيك ايكويشن اللي هي ام سكوير بلس لامدا سكوير سي سكوير ايكوال 0، وده هيؤدي الى ان ام سكوير ايكوال بوزيتيف اور نيجاتيف لامدا سي اوف اي. طبعا ده الجزء الكومبلكس، سوري معلش انا جديد بس نطيت حركه غصب عني. ده كده ام 1 انا وديت لامدا سكوير سي سكوير من ذا اذر سايد سو از جونا بي نيجاتيف، خدت سكوير روت في النص سايدز جبت الجزء بتاعتي. طبعا بيزد على ان ده كومبلكس، يبقى في الحاله دي الروتس او الجنرال فورم هتطلع. بص بقى زي دي، ادي اكس هيساوي خلي بالك a times cosine of lambda c of x plus another constant which is sine c lambda of x، حاجه بالشكل ده. انا سميتها ده E1 و P1. كده انا قدرت اصولف الاكس بارت in a similar manner، نفس الاسلوب بالظبط. try to solve الجزء الثاني اللي هو خاص بالتي، نفس الستبس انا بعيدها تاني. يعني ده معناها ان تي دبل داش خلي بالك بقى divided by t will equal to negative lambda square. that's gonna lead to ده هيودي لك لايه؟ انه t double dash plus lambda square over t equal to 0. الستيب اللي بعديه يبقى ده